Exercise 1. Create a script that checks a numerical vector and forces its value within the preset range. That is, if the value is less than the low bound value, set it to the low bound value. If the value is greater than the upper bound value, set it to the upper bound value. This is a description of the programming task. We need to look at three things. First, what are the data to be processed by the script? Here we have a numerical vector, a low bound value, and the upper bound value. Next, we're going to look at what the script will accomplish. And it says that it will confine the values within certain range, and the range is defined by the low bound value and the up bound value. Lastly, we need to check what is the outcome of the script. And it is the updated numerical vector. Once we are sure that there is no ambiguity in the description of the script, we need to determine the steps of solving the problem. There are typically three steps. The first step is to determine the input data. Here we have a numerical vector, an upper bound value, and a low bound value. Next is to determine how to process the data. And in this case, what we're going to do is to check every value in the vector. If it is below a low bound, we set it to a low bound value. If it is above the upper bound, we set it to the upper bound value. Once we did that, then we get an updated vector. And this updated vector will be used in the third step, which is to define the output data. Next, we're going to create the pseudocode of the script. The first part of the pseudocode is a head comment. You can use the template provided to create the head comment. You can also create your own style of the head comment. In the head comment, there are a few things you need to fill in. The first is a script file. This is the file name you use for this script. Second is called purpose. It's a description of what the script will do. And it is typically the description of the program task. The third section is a record of revisions. It will show the date, which usually is the date that the script is created, and then the programmer, which is usually your name, and lastly, the description of the change, and it can be the version number. You can make it as the initial version, or you can say it's version 1.0. If you make further modifications later, you need to add any modifications to the script in the purpose area, and also change the date of the modification as well as the version number. Last section is the variable list. Those are the variables you used in the script. They are the primary variables that carry the data step by step. And in this script, we will use three variables. The first variable is data vector, which is to hold the numerical data vector. The second variable is called low bound, and it will hold the low bound value. The last variable will be the upper bound, and it will hold the upper bound value. After complete the head comment, we move to the next section of pseudocode to describe the steps of the script. We will follow the steps listed in the previous slides of script analysis. The first step is for data input. There are three sub-steps. They are: input the numerical vector to variable data vector, input the low bound value to variable low bound, input the upper bound value to variable upper bound. Next, we're going to generate the pseudocode for data processing. And we're going to use a for loop. So we will list the pseudocode as iterates through the variable data vector using for loop. For each value in data vector, we're going to compare it to low bound value. If it is less than the low bound value, then we will replace it with the low bound value. Otherwise, we will check to see if it is more than the upper bound value. If that's the case, we'll replace it with upper bound value. Lastly, we will generate the pseudocode for data output. And in this case, the process the data will still be in the variable data vector. So the pseudocode will be output the data vector using the function fprintf, and we will specify that we'll output one value per row. You can use a MATLAB script editor to enter the pseudocode. In this case, you should make the pseudocode in the format of comment. And once you finish the pseudocode there, it will be very easy to translate the pseudocode into MATLAB statements.